Welcome to our notes on solving one variable inequalities on number lines. Students will be able to solve and graph single variable inequalities on a number line. Example 1. Let's first graph x is greater than or equal to 4. Okay, so x is greater than or equal to 4. Since I can be equal to 4, I'm going to put a closed circle on 4. And x values that are greater than 4, think 5 is greater than 4, 6 is greater than 4, 7 is greater than 4. That means I'm going to draw an arrow this way. All right, so let's think about another way of writing x is greater than or equal to 4. Let's talk about 4 as it relates to x. Okay, so this time I'm writing 4 first and not x first. Well, to keep the relationship the same, the thing that is greater has the inequality facing it. So x is greater than or equal to 4, which means I still need to have that inequality open to the larger thing. So I read this as 4 is less than or equal to x. That is equivalent to x is greater than or equal to 4, and they both will produce this graph. Example 2. Graph x is greater than -2 and x is less than or equal to 3 on the same number line. I'm going to do some work here. I'm going to ask that you hold on taking notes until I explain everything. So whatever I graph on this number line has to satisfy both of those inequalities. So if I were to graph them separately, I would graph an open circle on -2 and all x values that are greater point to the right. Okay, I'll take a different color this time. And x is less than or equal to 3 means I'm going to put a closed circle on 3 and I'm going to move all the way to the left. Now, whatever I graph has to actually match both. It has to satisfy both inequalities. Well, what satisfies both inequalities? Having the open circle on -2, the closed circle on 3, and cutting everything else out. Okay? What overlaps is the solution here. Okay? So I have to cut this part off because even though it satisfies x is less than or equal to 3, it does not satisfy the fact that x is greater than -2. And similarly over here, this part right here satisfies x is greater than -2, but not x is less than or equal to 3. So it has to satisfy both. If you want to write all of it, that's fine, but this is the one that you absolutely need to write on your paper. Typically, and inequalities like this one are not written like this. If we rearrange this inequality, x is greater than -2, as -2 is less than x, then we can combine these two together and it becomes that x is between these two numbers like so. And so that makes way more sense when you see it this way. Okay, you can see that x is in between -2 and 3. Okay. Okay, now we're going to start solving one variable inequalities. I'm going to kind of show you two ways of solving this. One is more of a traditional way, using the inequalities only. The other is solving the equation and then using test points. So you can choose which way that you like. I'm going to show you example 3 in both ways, and moving forward, you will be able to choose which method you like the most. All right, example 3, 15 is less than or equal to 5x. By the way, if you do like the graphic organizer and you wish to continue using it, I will start putting it here, but I won't go through it in this set of notes. Okay, this first method is the traditional method. Okay, I would like for you to watch the traditional method as well as the other method I'm going to show you. And then once you decide which one you want to use, then take notes. Okay, so this is just the traditional. That means only using the inequalities as they are. So in order to get x by itself, I have to divide both sides by 5. Okay, That's what the graphic organizer tells me. It says divide both sides by 5. So I end up with 3 is less than or equal to x. And I understand that that might make some people uncomfortable. So you can go ahead and rearrange by writing x first. And the inequality should still face x. So it now says x is greater than or equal to 3. So what we're going to do is we're going to put a closed circle on 3, and all the x values that are greater than it will be highlighted. So here's the second method, test points. So whenever I see an inequality, instead I'm going to treat it like an equal sign. So I'm going to rewrite this as an equation. And now I'm going to divide both sides by 5. X equals 3. What that does tell me is that I'm going to have a closed circle on 3. And it's going to be closed. I know it's going to be closed because I originally started with less than or equal to. Okay? So be mindful. Now, what I'm going to do is I'm going to test a point to the left and to the right. So let me change colors. Let's say I test x equals 0. I'm going to put x equals 0 in here, and I'm going to see if my inequality holds true. So 15 less than or equal to 5 times 0. That means 15 is less than or equal to 0. Well, that's not true. So because it's not true, I actually need to shade the other side. Okay, now what if I tested, I don't know, I like to write test down here, hold on, test x equals 5. What would that look like? 15 is less than or equal to 5 times 5. 15 is less than or equal to 25. This holds true, so I would shade the side where it's true. Okay, if it was false, I would shade the other side. So you can also solve inequalities this way. All right, now that you have seen both ways, I do want to let you know that there are times when traditional makes more sense to do. Like for example, this example in particular, it was a lot easier to do the traditional method. Nothing changed really. You know, I kept the inequality the same until I rearranged it here. And it seemed like testing points is a lot of work here, but when these one variable inequalities become more complex, such as the next example, then it might make a little bit more sense why testing points would be beneficial. So at this point, you can choose whether or not you want to watch the traditional part of this video or the test points part of this video or all of it. All right, so here is the traditional method for example 4, and I have the graphic organizer to the left for those who like to use it. What happens when we multiply or divide by a negative number? The inequality symbol actually switches. So first let me just show you how to do it traditionally, and then I will explain why the symbol switches. I'm going to divide both sides by negative 5. I get negative 3 is greater than or equal to x. And then I'm going to rearrange so that x comes first. The negative 3 is what's is larger. So now I'm going to graph negative 3. And all x values are less than or equal to that. So that means I'm pointing this way. All right, why does the inequality symbol switch? I'd like to show you that. If you don't want to write this down, that is completely fine, but at least watch this part of the video so you understand why it switches. So this coefficient in front of x is negative. It's a negative 5. Usually we like to see positives in front of the coefficient, but this time it's negative. So I'm going to do this. I'm going to rearrange this inequality by adding 5x to both sides. The 5x and the 15 cannot combine because they are not like terms. So I actually have 5x plus 15 is less than or equal to 0. And then I'm going to subtract 15 from both sides. And I have 5x is less than or equal to negative 15. And then I can divide both sides by 5. X is less than or equal to negative 3, which is the same result that we have here. This is the reason, this is the algebra behind this. So if you can understand that whenever you multiply and divide by a negative number, you just need to switch the inequality, you can actually save yourself some steps, okay? Because it took this long to get to the same result. All right, even if you solve this traditionally and you forgot to switch the inequality, let's say here you ended up getting negative 3 is less than or equal to x, which then gets rearranged as x is greater than or equal to negative 3. Again, everything in red, you do not have to write. If you did that, you would probably go ahead and put the closed circle here and have it face that way. And here's another reason why you might want to test points or practice testing points. If I were to pick 0 here and I were to plug it in to this inequality, I'm saying 15 is less than or equal to negative 5 times 0, which is 0. Is 15 less than or equal to 0? No, it's not. It's false over here. So I really should not be shading over here, which means I need to shade this way. But then if you were wondering exactly why that happened, I showed you earlier with the steps, okay? So that's the traditional method. All right, so I'm going to solve this in the more traditional way. You can also solve this the graphic organizer way that I showed you before if you like that. We've seen that multiple times. I'm just going to stick with the algebra and showing the steps each way. So the first thing I'm going to do is add 4 to both sides. So I'm left with 10 is greater than negative 3x. Okay, I'm going to end up dividing by a negative. That means I have to remember to switch my sign. So 10, this is negative 10 thirds less than x. Okay. So negative 10 over 3 is not going to simplify to a nice number. So I'm going to have to estimate where this is on the number line. So I asked myself, how many times does 3 go into 10? It goes into 10, negative 3 times, and then a little bit more. So in fact, 1/3. So this could be, so negative 10 thirds is negative 3 and 1/3. Okay, this is the improper fraction. This is the mixed fraction. If you ever hear that language, that's what that means. So negative 10 thirds is over here. And I'm going to use an open circle on it because it says less than. It doesn't say less than or equal to. I also like to see my x's written on the left side. So I'm going to rearrange, and I can rearrange like that. X is greater than negative 10 thirds means I'm going to shade to the right. Okay. Example 6. Now we're dealing with and inequalities. That means, we have an expression squeezed in between two others. So for the traditional method, I probably would not split up this and inequality like this for the traditional method. I'm actually going to use this one to show you how I solve. So I'm going to go ahead and rewrite it the way that it was given. Okay, now I'm going to subtract 4 from all sides. Okay, so notice I subtracted it from the middle, the right, and the left. Okay, whatever I do, I have to balance everything. So this is negative 2 is less than or equal to negative 2x less than 4. And now I have to divide everything by negative 2. Now, because I'm dividing by negative 2, that also changes all of my inequality symbols. So negative 2 divided by 2 is 1. I'm going to write greater than or equal to this time. X greater than negative 2. And this is not typically how we write and inequalities. We always rearrange. So that means I have to write this first. and then less than x less than or equal to 1. So do not just go straight down like this, okay? This whole thing has to be flipped. Okay, so you write this, then you change that symbol, then this one, then this one, then this one. And that will help us graph. So -2, 1, close circle, and it's in between. All the x's are in between, and that is my solution. All right, so here's the last example, or inequalities. Okay, so here's a traditional way. I'm going to solve and graph this or inequality. Either x minus 8 is less than or equal to -12, or 2x is greater than 12. Since these are both one-step inequalities, I'm not even going to bother writing the PEMDAS inverse table. The PEMDAS inverse table really helps when you have 2 or more steps to do. Okay, so I'm going to, oops, that's large. Okay, I'm going to add 8 to both sides. X is less than or equal to -4. And then I'm going to solve this one. I'm going to divide both sides by 2. X is greater than 6. And so x is less than or equal to -4. It means I'm going to put a closed circle on -4. And I'm going to have it face this way because all x values are less than it will face to the left. And x is greater than 6, open circle facing to the right. So my final answer is x is less than or equal to -4, or x is greater than 6. Okay, so here is the testing points method. I have the graphic organizer to the left for those who like to use it. So I'm going to take this inequality, and instead of working with the inequality, I'm going to solve the equation. So I'm going to go ahead and just write it over here. 15 equals -5x. I'm going to divide both sides by -5. I end up with x equaling -3. So I'm going to put a circle here, and I'm going to put it closed circle because the original says less than or equal to. So that means I can be equal to it. Let's see, here we go. -3 is right here. I'm going to go ahead and fill that in. Now, which side do I test? Okay. I like to pick 0. 0 is really nice if it's not one of my values that I'm plotting, right? So I won't pick -3, although I can just to test points. But I'm going to pick 0 to, it's a lot nicer to use. And I'm just going to plug it in. Let's see. I used purple last time. Let me use purple. 15 is less than or equal to -5 times 0. That means 15 is less than or equal to 0. Is that true? Nah, it's not true. So that means I'm going to shade the opposite way. It must be true on the other side, and I definitely want to check just in case. Let's see, running out of space here. Let's do this. 15 is less than or equal to, I'm going to test -4 this time. -5 times -4. Let's see, that's +20. 15 is less than or equal to 20. Yep, that's true. So I'm glad that I shaded to the left because that is my solution. But I have to write the solution algebraically. So this means that x is less than or equal to -3. Okay. Just a reminder, I tested x equals 0 here, and I tested x equals -4 there. Okay. So it works for this one, not for this one. All right, this is the testing points method for example 5. This means I'm going to go ahead and solve the equation, and then I will test points. So the first thing I'm going to do is add 4 to both sides. I'm left with 10 equals negative 3x. I'm going to divide both sides by negative 3. So I am left with x equaling 10 over negative 3, so negative 10 thirds. Since this is not a nice number as far as like graphing on this particular number line, I have to estimate this. Negative 10 thirds can be rewritten as negative 3 and 1/3. Okay, so you can get that. If you remember your fractions, this is an improper fraction and this one is a mixed fraction. So that means I'm going to go to negative 3 and a little bit more to the left, okay, since we're negative. So here is negative 10 thirds approximately. Now I have to test points here, okay? So I know that x and negative 10 thirds has some kind of relationship. I just don't know what to write in between. Am I going to write a greater than symbol in between, or am I going to write a less than symbol in between? The only way I can do that is by testing points. So I'm going to test 0. I like to test 0. X equals 0. That means 6 is greater than negative 3 times 0 minus 4. 6 is greater than negative 4. That is actually true. So I always shade the side that is true. So I'm going to put an open circle here because it is originally this symbol, which does not include the or equal to part. And then I'm going to go ahead and graph to the right. And what this says is that x is greater than negative 10 thirds. This is my final answer, and I'm done. Okay, so here's the testing points method for an and inequality for example 6. So for an and inequality like this, I actually have to split it up into 2. And usually I wouldn't, bother rewriting the inequalities because I'm going to use the equation instead. So I'm actually going to just go ahead and do that. And I have to solve both of these equations. So I'm going to follow the instructions. I'm going to subtract 4 from both sides. Negative 2x equals negative 2. Divide both sides by negative 2. X equals 1. Okay, this one I'm going to do the same steps. Minus 4 from both sides. Negative 2x equals 8 minus 4 is 4. Divide both sides by negative 2. X equals negative 2. So this is going to go onto my number line. Now let's see, which one do I have to do open and closed? Okay, so since the inequality here is not including the 8, this one has to have an open circle on it. The part of the inequality with the 2 on it has a less than or equal to, so I'm going to have a closed circle here. So I'm just going to write that for myself. Closed, open, so that when I come down here, I can go ahead and do that. So open on negative 2, closed on 1. Okay, so I went ahead and showed my work because it can be a little time consuming showing this on a video, but this is me testing x equals negative 4. I'm going to plug in negative 4 into the original inequality that was given, this one up here, and I'm going to test to see that everything works out. So when I plug in negative 4 in here, I get 8 plus 4, which is 12. Is 2 less than or equal to 12? Yes, it is. But is 12 less than 8? Nope. So this whole inequality is not true. I cannot shade over here, so don't shade over there. Testing x equals 0. Again, I'm going to plug in 0 for x. Negative 2 times 0 is 0. 0 plus 4 is 4. Is 2 less than or equal to 4? Yes. Is 4 less than 8? Yes. So it's true. I'm going to go ahead and shade inside. Now, to be thorough, I should also test to the right of this. So x equals 3. I plug in negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. Is 2 less than or equal to negative 2? Nope. So this is not true, so you don't shade over here. This is our solution when it's graphed. But our final solution is negative 2 is less than x, less than or equal to 1. Okay, so here is example 7, solving OR inequalities using the test point method. Because both of these inequalities are only going to take one step to solve, I didn't bother writing a PEMDAS inverse table for these, but you can if you like. So again, to not confuse myself, I'm just going to, ignore the inequality symbol and solve the equation. So I'm going to add 8 to both sides. Okay, I just want to know what I'm putting on my number line. So because the original said less than or equal to, that means I'm going to put a closed circle on x equals negative 4. So let me do that, and I'll scroll back up. So closed circle on this one just because of the inequality that we started. And then inequality 2, let's see. 2x equals 12, divide both sides by 2, x equals 6. Okay, now because this originally said greater than, that means I'm going to put an open circle on 6. And now I need to test to the left, to the right, and in between these values. So I'm going to choose, I can choose anything, even if it's not on my number line. So I'm going to choose negative 5 though. I'm going to choose 0 because it's my favorite if I can use it. And I'm going to choose, I don't know, let's say 7. Okay, so to save time, I just went ahead and did all the work, and I'm just going to explain it. When I'm testing x equals negative 5, I am testing relative to this value of negative 4, which I got from the very first inequality. So this is the one I need to check it for. Okay, so when I do that, when I test x equals negative 5, I plug negative 5 in here. Negative 5 minus 8 is negative 13. This is true, so I can go ahead and shade to the left. Okay, negative 13 appears to the left of negative 12, so that's why it's less than. Okay, now with x equals 0, there are two values I need to pay attention to. Remember, negative 4 came from the first inequality. This 6 came from the second, so I really need to check both. So I'm going to test x equals 0 for the first inequality. When 0 goes in here, 0 minus 8 is negative 8. Negative 8 is not less than or equal to negative 12, so that means I don't shade this way. Okay, so now I'm also going to check x equals 0 for the second inequality. 2 times 0 is 0. 0 is not greater than 12. So again, I don't shade this way. Now I'm going to check x equals 7. I don't need to check x equals 7 for the first inequality. X minus 8 is less than or equal to negative 12 because it is related to the second inequality instead. So x equals 7. 2 times 7 is 14. 14 is greater than 12, so I can shade the other way. Now you're not done. You have to, then put together your solutions. Okay, so this says x is less than or equal to negative 4. Or, because you can't be in both things, but you can be in one or the other. This one reads x is greater than 6. So I'm going to box my final answer, and that's it.